In this video, we're going to be demonstrating the operation of a Fisher. This is a Fisher L3. I think you can see there under the type there, Fisher L3 controller. So it's a pneumatic controller. We have, this should be our supply pressure on this side over here and our output pressure of the controller over here. But what it is, we're using this for our level measurement lab. It has a displacer here. You can see this displacer right here. It's about a 3-inch in diameter by 14-inch diameter cylindrical displacer. And what it uses is it uses a torque tube. So this is the torque arm right up here, and it drops down to the displacer. And you can see, if we look right up in here, might be kind of hard to see, but you can see the torque tube is going back this way, back over towards our controller. So if I just bring you back around over to the front here, you can see the torque tube, the end of the torque tube right up here. It connects to this flapper nozzle here. So as the torque, I'll just maybe move the displacer up and down, and you'll see this flapper nozzle. So there you can see I'm lifting. You can see the flapper moving up and down there. And right now I'm just lifting the displacer up and down here to get that motion. So as when the displacer is down, it's going to be covering the nozzle here, which is going to cause the pressure to build on our output here, and output a signal to our valve there to open it when the level drops. So basically a reverse acting controller, but our main focus is going to be the displacer over here and setting up and configuring our L3 controller here. All right, so the first demonstration here with the displacer, I have it, I'm hanging it here with this fish scale you can see, and it's weighing, if I let this stabilize, about 5 pounds, 6 ounces, I'd say. So I've got it just hanging here, and there's no fluid on it, so there's no buoyant force acting on the displacer right now. So I'm gonna do the same thing. I'm gonna put some fluid on this, submerge it, and see what our reading is. So yeah, we're reading about 5 pounds, 6 ounces. All right, so there now you can see that I've submerged this with our water with blue food coloring. You can see I've submerged the displacer there, and I'm still hanging it with our fish scale here, and now it's reading 1 pound, 6 ounces. So we've knocked 4 pounds off the weight. So now the apparent weight of our displacer is only 1 pound, 6 ounces. So we can use that information now to figure out our calculations calculate and prove our calculations for buoyant force. All right, so looking here at the flanged connection for our controller, you can see it's stamped right there, displacer size 3 by 14, and that's in inches. I just wanted to prove that. I've removed a displacer here, and I've got a tape measure sitting here. You can see that at 14 inches, it's about 14 inches in length or height. We do kind of have these rounded end caps, so if we're doing a volume calculation here, we might not get quite exact, but we should be pretty close. So 14 inches, you can see it kind of goes from right where the cap, the rounded end here kind of gets attached, or the furthest part of that before it starts to round off and turn to the top there. So yeah, 14 inches, and the other measurement was 3 inches. So just to kind of confirm that here, let's grab the tape measure here, and there, so I've got it towards right in the middle, and let's just have a look here. Should be pretty close. Yeah, so yeah, we're pretty close to 3 inches. If we go over it, you can see a little better at this angle. 3 inches, tape is at that end. So yes, so for our calculations here in the lab, what we're gonna be doing here is 3 inches in diameter and 14 inches in height. All right, so now what I've done here is I've calibrated this controller. This controller can either be used as a transmitter or a controller. So what I've done is I've calibrated it up to be a pneumatic transmitter. You can see over here, the output range for this device is 6 to 30. This could also be 3 to 15. Since this is a controller, it's likely 6 to 30 because the valve that it's going to be used with is bench set for 6 to 30 psi. So, but you can see right now, the output right here is at 30. It's kind of oscillating a little bit just because there's some vibration and stuff, and the flapper might be slightly vibrating. The You can see the displacer is actually kind of bouncing right now. But I also hooked up a gauge here to get more precise reading. It's bouncing a little bit around 30 psi, so right around 30 psi. So to do that, I had to adjust we're doing what they call a wet calibration, where I'm actually putting fluid on the displacer and calibrating it. So right now, it should be reading its lowest value here, which is kind of confusing here because this is actually set up for reverse acting. So right now, it's outputting its highest value. So in the levels at the lowest signal, it's going to output its highest value of 30 psi there. So I followed the instructions here, set it up for a proportional band of 10 or also 100%, which means we're going to get the output of the controller is going to change from the lowest value to the highest value throughout the entire input range here of the displacer. So if we had it set down for a low value of 0, it would be like on off. As soon as it got to one point, it would switch to fully open or switch to fully closed. So we need to use that proportional band setting at its highest value at 10 or 100% for it to function like a transmitter. And that's why I've set it that way. So we're at 30 psi. What I want to do now is I'm going to go ahead and I'm going to introduce a level here to show how it reads 6 psi, the lower value of the output range when we have it fully submerged. So I've calibrated it. I had to make an adjustment here on the flapper nozzle. That adjustment is done the way I have it currently with no fluid on it. We make that adjustment there, set it for our 30 psi we have over here. And then when we apply our, well, I'll go ahead and do that right now. I'm going to turn on and start filling up our vessel here. You can see the pressure is dropping off here as the level rises. I'm going to shut it off here right when it gets to the top. So we've just submerged the displacer, and you can see here we're reading, well, hopefully, yeah, down here we're getting a little better accuracy. Should be pretty close to 6 psi, so we're just a touch low, but pretty close. I'm pretty happy with that, because considering the adjustment here is these 2 screws. So we take these 2 screws and move this whole assembly back and forth to adjust the upper range value here. So the span, this would be the span adjustment. I know it is kind of confusing because this is a reverse acting controller, and right now we're actually at our lower value because it's a reverse acting controller. As the level rises, the output goes down. But yeah, those are the 2 adjustments. These screws here, and then the flapper nozzle there to adjust it. But you can see it's reading pretty close. What I'll do now is I'll just drain the level until about half of the displacer is submerged. Only half the displacer is submerged, and then we'll see our reading should be right in the midpoint of 6 psi and 30 psi. So I'd say we're pretty close to half there. Let's see. And yeah, we should be reading right around 18 psi. So we just kind of take a step back here. I guess our level could maybe drop just a touch more. Just maybe take a little bit more out there. Yeah, that looks pretty well, like half. And then we're reading pretty close to 8 psi. So we've got this set up now as a pneumatic transmitter. It's going to be sending out a signal of 6 to 30 psi based on the level, which is kind of confusing because 6 is going to be the signal for upper range and 30 for lower range. If we wanted to switch this for direct acting, we'd have to switch some stuff around in here, but this is set up this way so we can use it actually as a controller. And that's what I'm going to do now is I'm going to configure this. I'm going to switch this to be an on-off controller by changing the proportional band here. We've got it calibrated up as a transmitter. I'm going to quickly switch it over and just show it function. We're going to install this valve over here in the loop and show how it functions as a controller. All right, so now I have our supply here of 35 psi. You can see it's at 35 psi. It's going up here and into our supply on our controller. And the output here is then now coming out and over to our valve here. There's this 3-way valve installed here. So what this does is it allows me to run pneumatic right into the actuator here. So I don't have to, so I can bypass this positioner. If we were using an electronic loop, we'd use the positioner. But since we're using a pneumatic controller, it's just setting that 6 to 30 signal right into the actuator here. And the valve there, you can see it's throttling. It's about looking at the indicator there, it's about half open. And you can see we're sitting there, I don't know, right around half, a little bit below half. And I've got the level setting up here. It's set for halfway. So if I go ahead and raise this, we should see, if I go ahead and raise this, we should see now our level rise here. And then our valve should then throttle back, and our level should then stabilize again here. You can see it's slowing right down. And I'll make an adjustment here. We'll go down below 5. I set it to 3. And you can see our level coming down now, and then the controller controls. So just keep in mind here that what this controller is, it's throttling. The controller's throttling the level, and looks like we might even go a little bit below here. So what we might have to do is adjust our gain, because we've got this at 100%. It's really high. So what I'm going to do is lower it, and that'll increase our gain setting. It'll act more like an on-off controller. So I'm going to put it down to about 3 or 4. We're going to just test this out and just see how it reacts. So there, it's a lot more fast acting, you can see. I'm going to lower our gain even a little bit more. And there, now we've reached the point where we put it into oscillation because the gain's become so high. And technically, if we wanted to do a tune on this, we could. But for now, just showing you how we adjust that gain, I'm going to increase the proportional band, which is then going to, I was down around here. I'm going to increase this gain to about 2 or 3, and this should make it a lot faster acting now. So if I want to lower this level here, it should drop down. And there, it's a lot faster acting. The one thing about this controller here is that it's proportional only, so it would suffer from the offset. It doesn't have an integral setting in it. So, but yeah, you can see the controller aspect of it seems to be functioning quite well as well. So we can set it up to be a transmitter. We can set this up to be a transmitter or a controller. And over here we're using the valve there to throttle the flow. So the valve is about 3/4 of the way open right now, and it's maintaining the level there. You can see it's not rising or falling. The water is draining out the bottom here back to our tank, and then our pump is pumping off that tank and pumping the fluid up into the top of our vessel, and it's just continually circling. The displacer is relaying the level measurement onto the controller, and the controller is then adjusting an output pressure over to our valve here. So this would be our proportional band or gain setting, and this can be used here as our set point up there for our controller. So we got it working. It's working great.